Welcome back. This is the continuation of standard P6C. So looking at these last two problems here, in this first problem, again, the general strategy to when we're doing these is we got to make this into one single fraction, and we need to make this into one single fraction. After we've achieved that, then we can sit there and divide these two out by multiplying by the reciprocal. So starting with our top fraction, the one that's in the numerator of our complex fraction here, we have 2 plus 2 over x. Now officially this is 2 over 1 right now. So since we have an x in the other one, we need to multiply this by x over x to get that common denominator. And when we do that, we're going to get the fraction of 2x over x plus 2 over x, which is then going to be able to be written as 2x plus 2 over x, which, if we want to go just one step further, we can factor out the top already, and we can write that as 2 times x plus 1. Now, all of this is in the numerator of our giant complex fraction here. As we look at the denominator here, again, we have 3 minus 3 over x squared. Since we don't see anything under that first 3, we can put a 1. Looking at this, if we have the denominators of 1 and x squared, we know that our common denominator is going to be 1x squared. So we need to multiply this by x squared over x squared. When we do that, we will have 3x squared over x squared minus 3 over x squared. And from there, we can sit there and combine those together. Since we have common denominators, we'll keep that common denominator. And in the numerator, we will have 3x squared minus 3. Now, last but not least, if we look at that, we can see that that numerator is able to be factored. So if we pull a 3 out of it, we'll be left with x squared minus 1 over x squared. Now, at this point, we have done a whole lot of work to sit there and show you how we're getting to that point. Now, this is what we've really been striving for, is we've gotten it to be just a fraction over another fraction. And when we have that, we can rewrite that as the rational expression 2 times x plus 1 over x divided by 3 x squared minus 1 over x squared. Now, when we divide rational expressions, what we really do is we multiply by the reciprocal. So again, we are going to rewrite this. If you are able to jump and kind of skip this in-between step right here, that's absolutely okay with me, but you want to make sure you're doing that very carefully. So now we're multiplying by the reciprocal instead of dividing. One thing to notice about this is that this is actually a difference of two perfect squares. So we can factor that as we go and make that into an x plus 1 and an x minus 1. Now to multiply these, we go straight across. So we will get 2 x squared times x plus 1. And in the denominator, we will get 3x, x plus 1, x minus 1. At this point, we should go through and restrict our domain. In fact, all of these, our domains really should be restricted. I know it's not something we're stating up here explicitly. We're just assuming you know how to do it at this point. But in this particular problem, if we wanted a refresher, we would say x cannot be equal to a negative 1, and x cannot be equal to a positive 1. And x cannot be equal to 0 because we have just that single x sitting out front. Looking at this, we can cancel. That's good. We can actually cancel out this x with one of the x's up top, leaving us with just one of those. And looks like our final answer will be 2x over 3 times x minus 1 with these restrictions. And it's really, I wouldn't call that an easy process, but that's all it is. It's making your complex fraction, right? Fractions within fractions, making the top and bottom both fractions. Once you've achieved that, then you can come over here and you can rewrite that as a division problem, which we can then turn into a multiplication problem by multiplying by the reciprocal, right? This moved down here, this moved up here, factoring and simplifying all the way along like we've been practicing for the last couple of days. Let's look at one more of these problems together. Here it is. This is a good situation because the bottom is already one single fraction. That means right off the bat, we have nothing to do with that fraction. So, looking at the top, currently we have 3 over 1 plus 1 over x plus 4. Now, in order to make this a common denominator, right, essentially this second fraction already has a 1 sitting here. So that part's kind of taken care of. The part the first fraction does not have is that x plus 4. So we need to multiply by x plus 4 to give it that part. Moving along, I'm just going to kind of work through just the numerator of the fraction here because our denominator is not going to change. So I'm going to get 3x plus 12 when I distribute that. So I get 3x plus 12 over x plus 4. And then I want to add that to 1 over x plus 4. Since I have common denominators, I can push those two together. We will keep that same denominator of x plus 4. But our new numerator will be the combination of this first numerator and the second. So 3x plus 12 plus 1, we'll have like terms with the 12 and with the 1. So those can be combined. So I will get 3x plus 13. And looking at that, we can't factor, we can't simplify anymore. That's as far as we can go. Now, fortunately for this problem, our denominator was already one fraction for us, so we had nothing to change. So we can come over here and just rewrite this like so. At this point, we've now turned this into a division problem. Again, this is the step you can skip writing if you know what you're talking about. It is good to show this step, though, as you're first learning this, right? We're really saying take that top fraction, divide it by that bottom fraction. And in math, what it really means to divide a fraction by another fraction is the exact same thing as taking the first fraction, not changing it, but multiplying it by the reciprocal of the second fraction. So the reciprocal is the flip of that fraction. So now we'll have x plus 4 in the numerator and 2 in the denominator. Multiplying that out, again, this is a quantity, so we should leave those parentheses on that right now. 3x plus 13, x plus 4. And on the bottom, we'll have 2, x plus 4. And again, this would be a good spot to restrict our domain. So x cannot equal a negative 4. Cancels, cancels. We'd be left with 3x plus 13 over 2 as our final answer, with x not being able to be equal to a negative 4. Now again, with the restricting the domain piece, that is something that we should probably be doing in all of these problems, but for some reason with these complex fractions, there seems to be a lot going on, so that is often a piece that's not expected of you in terms of directions. Just make sure you're reading your directions. If it's telling you to restrict your domain, do it. I'll try to be very explicit whenever I want to see it from you to make sure you know what you're talking about, but this is how we work with complex fractions. Again, get the expression to be written as one fraction over another fraction. So if we have a lot of business going on, we got to convert those into one fraction first. From there, change the division to a multiplying by the reciprocal, and then of course go through and simplify as you are used to. If you have any questions, again, make sure you're reaching out to me. Hopefully this goes well for you. Have a great day. Talk to you soon.